3, go.
Hello, we are the team at Robots. To start off, I'd like to thank our two sponsors, MathWorks and IEEE, for providing us with software and financial support. This year we built two rovers. These are scientific instruments which are set to explore another extraterrestrial part of the universe, and they collect data, and they have a bunch of sensors that collect data. These sensors are all connected to the adrenals which are connected to the USB extender. The USB extender and the camera are both connected to our network, which is provided by our router. Our computers are also connected to that, which creates our mission control. Then the camera, which just shows there, that way we know what the planet looks like, and then the USB extender will show all the sensor readings. Alright, now passing it on to Jonathan to talk about the motors.
So we have a autonomous rover and a manual rover. The manual rover here uses two motors and two ultrasonic sensors. Originally, the NXT motors were not powerful enough and couldn't move the rover, so we had to switch motors. And so it works by having each ultrasonic sensor coordinating to each motor. And so if it's greater than 30 centimeters, they sense, it will go full speed forward. If it is less than 30 centimeters but greater than 7 centimeters, it will turn the corresponding motor backwards. So for instance, the left motor here, it will turn this motor backwards. And so if it is less than 7 centimeters, however, it will do a pre-program. It will back up and turn around and back up, so that it can avoid any close objects that might appear like at the last moment before it can sense it. So manual rover works with the remote here, and so each lever corresponds to each motor here. The further forward you push it, the faster it will go. There's also a button here for the case protector on the back here, and if you push it, it'll go down, as you can see. And there's also an active brake system which will stop the rover under any conditions if the ultrasonic sensor is blocked, as you can see here. And now for some external sensors.
So between the two rovers, we have a multitude of sensors, including the pH detector, the light detector, the moisture detector, the metal detector, the petroleum detector, and we have thermometers and thermoresistors on both rovers. So the pH detector works with the leakage of hydrogen ions from the reference electrode to the opposite electrode. This creates an electrical current, which is then measured by detection units within the sensor and sent to mission control. The light sensor works when light is shined on the photovoltaic cell located on the sensor. This photovoltaic cell will put out more energy to the more amount of light it is exposed to. This electricity is then measured and then sent to mission control. The moisture detector works as the amount of electricity produced is a direct function of the amount of moisture in the environment. The more moisture you have, the more electricity that will be produced. This is then shown on mission control. The hydrocarbon detector, also known as a petroleum detector, works with a catalyst located within the detector. So when petroleum and other carbon-based substances come in contact with the catalyst, it will cause the catalyst to react with the carbon-based substances. This is then recorded on the mission control screen. The metal detector works when a piece of metal is placed within a magnetic field created by the metal detector. The disruptions within the field are then measured and sent to mission control. The thermoresistor and the thermometer work with the Wheatstone bridge. So basically, the Wheatstone bridge converts the changes of the resistance to changes in voltage. These voltage changes are then recorded on the mission control screen.
And that concludes our presentation.
Right.